So for today I'm going to do two different problems, and the first problem I will be doing is problem number 1 from section 4.8, which states find the antiderivative of each function. And the antiderivative is working backwards, so you're going from the derivative function, finding that original f of x, whereas the derivative was going from f of x to find f prime of x. And our general rule for finding the antiderivative, the definition of f of x, so the function that we're looking for is equal to 1 all over n plus 1 times x raised to n plus 1 plus c when n does not equal a negative 1. And in the c is standing for the constant, so 5, 25, any constant number, and n is the original power that the function of the derivative is being raised to. So in this, looking up here at 8x to the 7th, n would be 7 here. So that's what we'll start with that for the first problem example we'll do. So a, f prime of x equal to 8x to the 7th. And so then we set that up as 1 all over n, we said n equals 7. So 7 plus 1. Oh, and before we do that, the constant here, the rule of the constant, the 8, we'll just pull that out in front, because we're going to multiply that by that. So we have 1 all over 7 plus 1 x raised to 7 plus 1 plus c. And then we simplify that, we get 8 times 1 all over 8 x to the 8th plus c, which then we get, cancel those 8's out, and we are left with x to the 8th plus c. And that is the antiderivative of 8x to the 7th. So then for part B, f prime of x is equal to x to the 13th. And I'll rewrite the formula down each time so that we can see it. F of x equal to 1 all over n plus 1 x to the n plus 1 plus the constant when n does not equal a negative 1. And n does not equal a negative 1 because if we did negative 1 plus 1, we would get 0, and we can't divide by 0. So x to the 13th here, b of x to the 13th, n is equal to 13. So then I have 1 all over 13 plus 1 x raised to 13 plus 1 plus the constant. And when we rewrite that, we get 1 all over 14 x raised to the 14th plus the constant. And that is the antiderivative. 1 over 14x to the 14th plus c is the antiderivative of x to the 13th. So then part C, the third one they want us to find, f prime of x equal to x squared plus 4x minus 21. And so where f of x, again, is equal to 1 all over n plus 1 x raised to the n plus 1 plus the constant, n cannot equal a negative 1. In this equation here of c of f prime of x equal to x squared plus 4x minus 21, we're going to have different n values. So in this x squared, n is going to equal 2. I'll write it underneath. In this, because we do each part separately, just like we would do the derivative of the sum rule, 4x, you can imagine that we have that raised to the 1. So n is equal to 1. And in the negative 21, n is 0, because if you had x here, pretend we have x here, and you raise it to the 0, anything raised to the 0 power is 1. So then you would have a negative 21 times 1, which is still a negative 21. So then to write this out, we start with the first term of x squared. So we have 1 all over n being 2, so 2 plus 1, x raised to the 2 plus 1. And they're all going to be plus the constant, so I usually wait till the end and just add that constant n at the end. So then that takes out this term. Then we have plus, for 4x, we're going to pull that constant here out in front. Then we have 1 all over, remember n is 1 in this case, so 1 plus 1, x to the 1 plus 1, just like that. Then that takes out this term. Then we have minus 21, 21 is our constant, times 1 all over 0 plus 1, because n is 0, x raised to the 0 plus 1. Then I'll plus my c over here really tiny. When we simplify this all down, we have 1/3, 1 over 3, x cubed, plus, now here we have 1 plus 1 is 2, 1/2 times 4 is just 2, so we get 2x, 1 plus 1 is 2, is 2x squared, minus, we have 21 for the constant, times 0 plus 1 is 1, 1 over 1, x, raised to the first power, so we can just leave it as x. And then we just have that plus c. So then our final answer for this is, our function x squared plus 4x minus 21 is 1/3 x cubed plus 2x squared minus 21x plus c. So that's how you find a few antiderivatives. But then for the second problem that I'm doing, so that was 4.8, number 1. I'm going to do 5.2, number 2, which is simply write out the sum without sigma notation, then evaluate. So we have 6 and k equal 2, and the function sine k pi. So this function is going, the interval kind of is from 2 to 6 on the values we're going to plug in for the k interval. So 4k. And if we write this out without sigma notation, we're just going to write each part out simply as using this. And we'll plug in for k values from 2 to 6, which leaves us with sine 2 pi plus sine 3 pi. And we just keep going until we hit 6. Plus sine 4 pi plus, move this down here, sine 5 pi plus sine 6 pi. So this, written out all complicated, not in sigma notation form, is each part added together. Then it says, so this is the first answer, and it says to write that without sigma notation. Then it says to evaluate. So when I took sine 2 pi plus sine 3 pi plus sine 4 pi plus sine 5 pi plus sine 6 pi, and I calculated that in my calculator for each value, I was getting 0 or very, very close to 0. So when we evaluate this function, we get equal to 0. So I'm going to 6k equals 2 of the function sine k pi is equal to 0. And that is how you solve 5.2, number 2.